Hello, good morning. Um, my name is Julius Musseau, and I'm here to present 6 ways known vulnerabilities sneak into Docker containers. A little information about me. So I'm an active software engineer, hands-on active software engineer with around 20 years experience writing software. These days, I spend most of my time writing Java and SQL for MergeBase, which is an application security startup I co-founded in 2018. And I really want to emphasize that I'm actually a hands-on application developer. I'm the kind of person who is, causing probably a lot of the people at this conference right now headaches and grief, because I'm the person that's writing the vulnerable code and that I'm then, committing into my my systems and deploying and running. And as an example, in 2006, or maybe it was 2007, I wrote a open source library called Not Yet Commons SSL. It was maybe not that popular or widely used, but it was used enough that after a few years, in 2014, Red Hat sent me my first patch, because they had noticed, their researchers, I guess, Red Hat had noticed that it was vulnerable to man-in-the-middle attacks with the way it did the HTTPS. And so they assigned a CVE. So now, before that patch, no one had ever sent a patch into that library. And so, every line of that library had been written by me. And so, yeah, I actually really am 100% to blame for that CVE being in that code base. I know normally in security conferences, people like to brag about the CVEs they've discovered and not so much the CVEs they've caused, but I'll take what I can get. Okay, now, Docker containers have really changed software development. They've brought the developers and the ops much closer together. Right. In the old days, the developers would be responsible for the application code and maybe provide some input. Hey, it would run great on, Tomcat, or it'd run great on JBoss, but, that's ops has to deal with that. And then DevOps would be responsible for the platform. They might provide some input to the infrastructure team about the operating system and the hardware. And then the infrastructure team would, provision the hardware and install the operating system and get the networking going, right? So that's the old days. It's not like that really anymore. Times have changed. So now I find that developers and DevOps have come much closer together, which was always the dream, and I think leads to better outcomes. And now together they can work on the Dockerfile. Ultimately, the Dockerfile is going to combine the application code, the platform, the Java, the Wildfly, the PHP, whatever it is you're running. The operating system is in there too, of course, everything except the kernel version. And then even some networking kind of gets mixed in there a bit. The infrastructure team these days, they mostly just, click links in AWS. Now that we've got this set up with the Docker files and the Docker containers, right? Our job is, we're in an application security conference here. We want to vanquish the known vulnerabilities. Okay. Now, the problem here is developers historically have really sucked at addressing known vulnerabilities in their code and in their libraries. Now, and known vulnerabilities, of course, pretty much, how would you say, exclusively refers to libraries being brought into code. Like if you're, not everyone is going to have a CVE assigned to their work. That's rare. And even in that case, that was an open source library that I was developing, right? So the thing about developers, right, is they bring in all the libraries and they spend, it can take weeks to get your code integrated with the library and actually using the library properly. And then once it's working, you're so relieved and you're so happy that you move on to other things, right? The sort of the governing philosophy there is, if it ain't broke, why fix it? Why upgrade the library? Now, I'm not saying all developers suck at this, right? Anyone who's watching this talk probably is pretty aware about these issues. So yeah, in the old days, right, it's this this inner box was all that we really cared about, and we as developers we already sucked and continue to suck at addressing the known vulnerabilities in this inner box. But now that we have Docker, right, it's even worse, right? So I'm writing my merge-based application, right, for my startup, and it's got known vulnerabilities in its libraries, and I'm not really staying on top of that, let's say. But then I take the merge base and I deploy it alongside a Wildfly and a Java, right? Well, those are in this outer box here, well, the middle box. And those can also be bringing in known vulnerabilities. And then that middle box, it itself is sitting inside an Alpine Linux image with a bunch of Alpine Linux packages that have been installed. And those can also be bringing in known vulnerabilities, right? And so for each of these layers, the inner, the middle, the outer layer, or as we'll kind of flip that on its head and call them base, layer 1, layer 2, who's responsible, right? Who is keeping an eye on this and trying to get rid of these known vulnerabilities, right? So because of Docker and this containerization, it makes it easy to run the full stack in an isolated environment, but it also brings in a lot more scope in which known vulnerabilities can arrive. Right? They can arrive by the platform now, by the operating system. By operating system, I mean Ubuntu or CentOS or Alpine, right? Because what you're going to do if you need to extend the functionality of the operating system, you're going to install packages through the package manager. You're going to say, oh, I want to have curl and I want to have wget and I want to have OpenSSH, right? So instead of just downloading and compiling those, you're going to ask package management to bring those in. But some things, here's what I call platform, you will just download and compile. And then of course you have your application code. Now, some good news. There's a lot of Docker vulnerability scanners. Here's just to name a few: Aqua, Quay, SNCC, etc. There's even scanners built into popular container registries. Like, for example, if you upload your Docker image to Google Cloud Registry, boom, it's going to scan it right out of the gates, right when it arrives. Docker Hub, for example. And in this talk, I'm going to use Docker Hub. I'm going to upload all my images in this talk to Docker Hub, and we can see what the scan there thinks. But the bad news, as far as I know, as far as I can tell, they only scan the operating system layer. I've yet to find a container scanner that looks beyond the packages, the deb files, the RPMs, the APK files, right? Do they scan the platform layer, right? Like if I download Oracle database or MySQL and just download it myself and set that up, are the package scanners going to notice what version that is and check against NVD? No. So far, I haven't found one that does that. And then, my application isn't a public thing. It's a proprietary commercial application that I'm putting in a Docker container and, sending out to my servers or my customers or whatever, right? But it's made of all these libraries. So are these application scanners going in and looking at the libraries within my application? As far as I can tell, they're not. And that really might not jive with people's expectations, right? So, and then even more bad news is these application scanners, right? And then this is a screenshot, I think, from Aqua. They don't even know what they don't know, right? Like they don't say, oh, you installed a vulnerable APK file here, an Alpine package, and you installed a vulnerable jar, downloaded a vulnerable jar file into this as well, which is what I did, right? Instead of saying like, oh, we don't know how to deal with these file types, they're just saying, yeah, all green. I'm the one underneath my face there is green as well. They're saying, no vulnerabilities, good to go, all clear. And that's actually really bad that they're doing that. Okay, so for the rest of this talk, what we're going to do is I've got this image I've made based on Alpine, where I've installed Java and I've installed Jira on top of that, and I'm running Jira. And then we're just going to look at all the layers that were required to put together this Jira container, and just look at how known vulnerabilities can sneak in each of these layers. And then, have some discussion as we go along the way. As we build the layers, we're going to ask, how can known vulnerabilities arrive in this layer? And how can we detect those known vulnerabilities in that layer? And then, if we do have known vulnerabilities, what can we do to mitigate them? And then some homework, if people are running container scanners at home or at work, maybe ask yourself, does your preferred container scanner, is it able to detect the vulnerabilities at that layer? Okay, let's start. So just to start, I've got this, and it's whoops. Right, so these guys are the ones we're going to build based off Alpine latest. So these three are the three we're really going to focus on today. And then this one takes you to basically the setup screen. So you fire this one up, and it's like Jira, ready to set up Jira. And it's going to get a license, and it's going to fire up, what database you want to connect to, and let's fire up the plugin system and all that. So this one is the one after that. So, I got Jira all set up and ready to rock, and then I go and do the installation procedure and get a license. It's kind of wild. It doubles in size when it actually completes its configuration workflow. So this one is actually running right now. It's called Julius Musseau /Jira on the running tag, and you can see that yeah, I'm running it right now. So this is its console. So let's just go and take a look at that one. Great. So there it is. It's got some tickets. I can create tickets to another ticket. Another ticket has been successfully created. So this is the Jira. This is the goal, is to create a Docker container that can run Jira. Okay, back to the talk. So there's our running Jira, and look, I can even make Jira tickets. Yay. Okay, so I've split it into two Docker images. As you see here, I've got the this is my base. So basically the idea here is this one is just a useful image based on Alpine that also has Java, Oracle Java. And then, from this base image, we can then build other things such as Jira, or maybe there's other Java systems we want to set up and build on top of this base image. And that's a common strategy with Docker images, right? You don't tend to just cram everything into a single image. So here's the base Dockerfile. Just to go through that from Alpine latest, we're going to then we're not going to install any additional packages here, at least not from the package manager. We're just going to take Alpine latest, and then what we're going to do is we're going to download this this glibc Alpine package, but it's not maintained by Alpine. It's coming externally. It's coming from this Escarand person who's maintaining this. And then once that's in place, I'm going to download Oracle's JDK. Now, because Oracle doesn't give you a license to redistribute the JDK after you've downloaded it, so I'm just hosting it internally on my own server to make the Docker, work. Because you have to click through a end user license agreement to actually download from Oracle's website. So, I've done that, and then I've copied the file into my internal systems. And that's probably how a lot of companies would do it. They would take the JDK and host it internally somewhere now that they've acquired the rights to use it. Okay, now let's just go and build that. So there it is. Like I said, we're going to use this version of glibc. We're going to use that version of the JDK. So both of these are one version behind the current public version. That way we can, find some CVEs associated with them, right? So 233 has a lot fewer CVEs than 232. And again, JDK 291 is the current version Oracle publishes, so it has no CVEs currently published with it. Whereas if I go back to 281, it has some CVEs. And what am I calling it again? I'm calling it Alpine Java Base. Right. Okay, well, since I've already built it in the past, it just it's cached that before, so it's not going to redo anything. And now that it's built, oh, you have something I can do with dip my toes in it, just explore it a little bit. So I've got this this dip alias that I use just to explore these images. Right, and since I sent the entry point, I blank out the entry point, so it's not going to like start up some Jira or something. It's just going to do nothing. Oh, that's an Alpine image, I don't think. Oops, typo. And Alpine doesn't come with Bash, so I can't use Bash at it yet out of the gates, but there. Right, nice little Alpine image. You can explore it. There's the JDK I created. Okay, so this Alpine image looks like it's working well. Oh yeah, and so now that we've built it, let's push it to Docker Hub and enjoy a free vulnerability scan. So I've signed up for the, the personal Docker Hub, personal account or whatever, $8 a month, so that I get the vulnerability scans. So let's push that. I actually have already pushed it, but no harm in having it tell us that it already has it. Network's a little slow here. Yeah, layers already exist. Exactly. Okay. And now that it's pushed, I mean, you can go take a look, refresh that. And you can see they have this vulnerability scanning provided by SNCC. It's gone and scanned it, even though I went and downloaded a slightly stale version of Oracle Java, and even though I also downloaded that one version behind version of glibc, because those aren't coming from the package manager, because I'm downloading and installing them directly off the internet, essentially. Yeah, SNCC's not picking up that there's vulnerabilities there. Okay, moving on. Oh yeah, so when I do this dip thing, my alias dip, so if people aren't so familiar with Docker, like I was very confused about Docker until I figured out this alias, right? And so in particular, this is really key, the -ti. And so what I'm saying here is I want to run a command against the provided image. I want to, remove the container after the command has finished running. And I don't want to, I want to override whatever entry point the container normally has. So back here, so what I can do is I can take any of these, right? Like I can go like, let's take, CentOS even, right? If we want, it's like I can just dip my toes in, take a look, see what's in there. Like, oh, it's got, it's basically like having a fresh Linux to play around in. So I find that very useful when I'm working on these Docker images. So about that, yeah, the -i, like if I don't do the, so that -ti is really key. And if I don't do the -i, then nothing works. If I don't do the -t, it's So I can remove the -t, remove the init even, right? It's just like, ugh, like it's not even saying anything. Yeah, it's like that -t is so key. Like I just don't even know what's going on there. So yeah, the -i, the -t, they make it much more pleasant to be in those Docker images. Okay, moving on to the Jira Docker file, where we're going to build on this this base image we already created earlier. And again, I mean, Jira is pretty big to download, so I just downloaded it ahead of time and put it on my local server. Jira itself won't run without bash, so I'm going to ask Alpine, hey Alpine, can you install bash please? Right, so Alpine goes and installs bash, and then I download Jira, and then I untar Jira into this opt directory, and then I just had to do some shenanigans here just to get the Java home and the Jira home variables set. And they needed to be at the beginning of this file, and I just like couldn't be bothered figuring out a clever way to like prepend lines to a file. Unix is very good at appending lines, but not so good at prepending lines, or at least, you know, I'm not so good at prepending lines. And then, yeah, for this one, the moment the container starts, if we don't override that entry point, like I was doing earlier with my dip toes thing, if we don't override it, it's just going to boom, jump straight into start Jira in foreground mode. And that's really it, right? Like, isn't that wild, right? Like you have this from Alpine latest. It's only about, I guess that's like 12 lines of code. And then here is another, maybe another 12 or 13 lines, right? So in 25 lines of code, boom, you have a full running Jira, repeatable. Yeah, Docker's actually incredible. Okay, then let's see if we can build our Jira. Oh, don't know why there's a JPEG in there called cat on roof. So we're calling it, yeah, Julius Musseau Jira is, oh, don't go there. That's what we're calling it. Docker build. That's what I'm going to call it. I've already built it before, so it builds really fast. And let's push it up to Docker Hub. And then while we're waiting, let's go explore it a little. And now, you know, before I couldn't do bash, but as you see, since bash has been installed now, I can do bash. So I prefer bash myself. Explore, yeah. So in that earlier one, we had JDK, and I ran a Java command there. Oops, sorry. And now, but now you can see we've added to the image. We have this Atlassian directory as well. And then we have a Jira home directory, but as you can see, it's empty. It's just Jira wants there to be a Jira home directory. And when you run Jira the very first time, it's going to fill it up with all the good stuff that it needs. And that's essentially why it doubles in size from 800 megs to 1.6 gigs. So yeah, so we've uploaded that to Docker Hub. Right? And let's see what Docker Hub thinks. So there's my Jira. And, you know, again, right, like Jira, 800 or 500 megabytes of stuff. I actually have a slide on this. Build the Jira. 500 megabytes of stuff, right? And just, you know, again, Snick is saying, yeah, no vulnerabilities found. To me, that like it just goes against what I expected. I thought, hey, scan the containers, please. Let's find all the vulnerabilities. But no, they're really just looking at the package system. If anyone knows of a container scanner that's going deeper, let me know. Okay, so back up. So we saw this Jira image. I clicked on it. I built it. I pushed it to Docker Hub, right? We can see that it works. So now that we have this nice fully running Jira, where are the known vulnerabilities coming from? Right. So recall the layers, right? You have your the base image, right? And then we have our platform, and then we have our application libraries. And Jira has a lot of libraries. Okay, the layers of Docker. So let's go through them. Okay, now the base layer that's at the bottom of the stack, right? This is where our search for known vulnerabilities is going to begin. From Alpine latest, right? What do you get when you take Alpine latest and nothing else? Oh, I think before have a little diversion here. For building your Docker containers, what do you prefer, Ubuntu or Alpine? Now, if this was not pre-recorded, I would ask the audience, right? I'd say, raise your hand if you pick Ubuntu for your base image. Raise your hand if you pick Alpine, and someone that is going to yell out, CentOS, right? My prediction would be Alpine at this point is going to win 50% to 30%. And, lots of people just aren't going to raise their hands because people don't really like raising their hands. Okay, so I pick Alpine, and why? Well, let's look at this, right? Here's 3 base images that you could try out. Which one do you think is Alpine latest, right? So one of them is 5.6 megabytes in size. Another one is 73 megabytes, and another one is 209 megabytes. And you probably saw earlier on this window here, right? Here's CentOS latest, 200 megabytes. Here's Ubuntu latest, 73 megabytes. Here's Alpine latest, 5.6 megabytes. And that has implications for security. How many packages do they come with out of the gates? So I can do that. I've been dipping my toe in my images that I've been building, but I can dip my toe in these ones as well. Sadly, I won't have bash. I'll just have to use a shell. So apk-v info. Right? Like, look how few it is, right? They fit on one screen. It's 14 packages. That's all there is, right? You take Alpine latest, and out of the box, fresh Alpine latest, you've only got 14 packages. It's incredible. Ubuntu latest. Let's do the same with Ubuntu latest. Of course, you can't use this APK command because Ubuntu doesn't use Alpine packages. It uses Debian packages. So we'll use dpackage query command instead. Let's go take a look. Forgot to give a command. Okay, so dpackage query show. So there they are. That's all the packages it's come with. Right. Oh, I don't have less. Can I install less? I don't. Okay, now can I install less? Yay, I can have less. Isn't that something, eh? Alpine only has 14 packages, and yet it has a less command. Whereas on Ubuntu, which has 93 packages, well, it had 92, but then I added one because I've installed less. Where's less? I installed it. Yeah, so Ubuntu has 93 packages, and it didn't even come with less. And you can see that 92 here because I hadn't installed less. How about CentOS 8? Let's get out of there. And oh, just before, you'll notice I'm doing CentOS latest. You can see CentOS latest and CentOS 8. They both have the same image ID, so they're identical. And then for this one, yeah, RPM query dash all. Because CentOS is based on Red Hat Package Manager, so RPMs. Again, you have to use a different command to see all the RPMs that are installed. Do you have less? Okay, so that CentOS has that going for it. Comes with less. And yeah, 172 packages right out of the gates. So yeah, so that's why I pick Alpine, right? It has far fewer packages in the base image, and this means less attack surface. It also means fewer packages accumulating known vulnerabilities between updates. And then on top of that, right, I mean, if you take a look here, Docker pull Alpine latest, let's just see, like, is there any updates? I need to get a better internet connection. Okay, Alpine latest, CentOS latest. And Ubuntu latest. So, I mean, I pulled them, you know, this week as I was preparing for this talk. I don't think they've changed at all, but let's see. Huh, Ubuntu had an update. Well, that was exciting. Ubuntu latest 11 hours ago. But before that, and I had pulled it yesterday, Ubuntu latest, you know, it was 7 weeks old. So it just happens in the middle of this talk, there'd been a fresh update of Ubuntu. But that's 7 weeks, right? Without any updates, right? The 7 weeks for known vulnerabilities to accumulate. Whereas Alpine, right, 2 days old. And then this CentOS 6 months old. I mean, maybe, you know, if you have a Red Hat subscription, then, you know, maybe you're getting these every day or every week, right? Maybe if you're paying for a full Red Hat license, then you get connected to the good stuff. But in terms of what's just on Docker Hub, you know, Alpine is smaller, fewer packages in the base image, and they're updating more frequently. All of those are good things when it comes to reducing known vulnerabilities. Oh yeah, and then, so I did push Ubuntu up to Docker Hub just to see, like, just Ubuntu latest, right? And now that it's got even a fresher one, let's push it. So to do that, what do I have to do? I think I have to tag. So Docker tag, what did I call it? Julius Musseau Ubuntu. Okay, let's take that. So I'm going to tag Ubuntu latest. And I'm going to make a Julius Musseau Ubuntu latest. And then, so what I'm doing is I'm taking that image and copying it over to this name. And now that I've copied it over to that name, I can then push it up to Docker Hub. And that in turn will cause Docker Hub to rescan it. So, you know, this, as we see, is hot off the press, right? It's just updated 11 hours ago. And so in theory, this thing shouldn't have that many known vulnerabilities. Well, it shouldn't have any. And yet, after this is done, when I go to Docker Hub, we'll see, right? You know, oh, and then another thing I can do, right, is I can go into my image and even update it to absolute latest and greatest versions of all its packages, right? So, you know, I'm complaining that Docker Hub hasn't received an image in 7 weeks, but, you know, I can just go into my image and tell it to upgrade itself, right? I don't need to wait for a new image to arrive on Docker Hub. So let's do that too. Ubuntu. Or I'll just do it straight in my Julius Musseau one. So I just do apt-get update. And you do a dist upgrade. It tells it to upgrade all its packages. Oh, so it's even got some new packages. I'm surprised, eh? And so even though Docker Hub received a new version 11 hours ago, there's even more updates. And then what I can do is I can commit that. Okay, so that one, Julius Musseau Ubuntu latest, and I'm going to push that now. Nope, Ubuntu latest. And so you can see if I go into it now and do an apt-get update, it'll say it's all up to date, nothing to do. Yeah, nothing to do. So it's all good. So we're pushing that up to Docker Hub. Now that we even gave it a fresher upgrade than that 11-hour-old one. Even newer, so it should have even fewer vulnerabilities, essentially. Let's go and see. Really need to get faster internet, don't I? Okay. So here I go. Okay, it's in the middle of scanning right now. So we're just going to give it some time to complete its scan. And there you go. 1 medium and 17 Ls, even though it's absolutely at its latest and greatest, right? So I find this actually a bit frustrating because there's not really anything I can do about these. So I've taken like the minimal set of libraries that you can possibly have on an Ubuntu image. I've upgraded them to, absolute latest and greatest as of right this second. And the vulnerability scanner is still saying, well, you've got, 1 medium and 17 low severity vulnerabilities in your image. So that's kind of like, what do I do? Do I, start patching these manually myself? Do I, get Ubuntu on the phone? I just don't really know what to do about this. Okay, moving on. Yeah. So I'm in I think it right now Alpine doesn't have this problem, but I think partly that that's going to change eventually as Alpine gets more popular. And then maybe just like if there's not really anything the end users can do, maybe the scanners shouldn't be reporting vulnerabilities. That's one idea. So as we build the layers, we want to ask, how can known vulnerabilities arrive in the layer? How can we detect them? How can we mitigate them? Right. So for my Alpine base image, vulnerabilities might accumulate against those 14 packages, might be discovered and published. How can we detect them? Well, you can ask Alpine to simulate an upgrade. So it'll just tell you, oh, I want to upgrade these packages. And then you could go examine why, like, why do you want to upgrade these and see, oh, there's some CVEs. It's funny, like you'll see throughout this talk that identifying known vulnerabilities is doing it manually is a pain in the butt. Whereas using a container scanner is just so much faster. And then the other funny thing is that identifying known vulnerabilities is actually challenging unless you have a tool to do it. But mitigating them is very simple. You just tell your your image, you just say update yourself, right? So you can almost skip the identification part and just go straight to the mitigation part. So about this command here, you'll notice that my Docker files, they say, from Alpine latest, and then they just do the rest, right? So that's a bit of a mistake, really. My Docker file, the moment I'd done that, I probably should have done APK update, APK upgrade to make sure I'm on the latest and greatest according to the Alpine project, as opposed to according to whatever they pushed to Docker Hub. Do that. And I could do that on the Jira one too. Like I might not normally build these one after the other. So right. So even if I built the base image, a few months ago, now that I'm building my Jira image, it can still take advantage of the latest and greatest from the Alpine team. Yeah, so I mean, if you do that at the beginning of your Docker files, that's going to prevent known vulnerabilities. It's bad for stability and repeatability, right? Every time you build the Docker image, it's going to be a little bit different, right? Now, so that can cause breakage, right? Like you can accidentally get a bad version of Alpine when you do that, which will break your Alpine. But if you don't do it, you're going to have known vulnerabilities. So kind of your call. I lean towards doing the upgrade. Okay, next layer. Layer 1, the platform. So here, what we're doing is we're not using that Alpine package manager anymore. We're just downloading this glibc library right down off of GitHub, and then we're downloading Java directly to and installing it. I call that off-roading. Right? You're not in the package manager anymore. Now, the funny thing is that I do end up downloading an APK file and telling the Alpine package manager, please install this, but it didn't come from the official Alpine sources, right? It's not managed by them or tracked by them. It's just sort of playing nice with the package management system now that it's arrived. And then Java, I'm just untarring straight to disk. So what do the vulnerability scanners think? Well, as I've already shown you on Docker Hub, it thinks, let's go back here, right? Like here's this Jira one that everything was built off of, and nothing, no vulnerabilities found at all, nothing in the Java, nothing in that glibc, and nothing in Jira either. But if you go to NVD itself and look for Java CVEs or glibc CVEs, you'll see there's lots with these. So this is a bit of a weakness with the container scanners. I don't know. Does the audience here, did you guys think the container scanner should find these, or do you think, oh no, that's not their business? Need other tools for that. So how do as I'm again, I go through this question and answer sequence. As I'm building the layers, how can known vulnerabilities arrive now in this layer with this Java and this glibc? Well, of course, known vulnerabilities get, published against massive system libraries like Java or glibc all the time. How can we detect them? Well, we're going to have to do it manually. I guess we're going to have to kind of be aware, like, oh, we're doing this version of Java. Let's go and search NVD. We're doing this version of glibc. Let's go search NVD. That seems to be kind of the only option here, which is kind of nasty. And then how can we mitigate them? Well, since we're off-roading, whenever you off-road, that means you're taking responsibility for patching. You can't just say, dist upgrade or APK upgrade. You're going to have to see if there's newer versions. You're going to have to download them yourself. Or with this, sometimes there is an option, like instead of using Oracle's Java, I could use OpenJDK Java, and often that's a drop-in compatible replacement. And so if I do that, I'm switching from off-roading back into the package manager. And so then I can do dist upgrade, or I can do APK upgrade, and it's going to keep OpenJDK up to latest and greatest. Okay, now the application. Jira. Unleash the Jira. So we're downloading this Jira tarball and we're just untarring it right onto disk. Again, same question. Should we do the APK update and APK upgrade? I think so, right? My Alpine Java base might be a bit stale, so running update and upgrade mitigates that staleness a bit. And of course, I mean, that's not going to cause glibc or Java to be upgraded, but everything else will. So it helps. And then now here comes Jira, 500 megabytes of HTML, CSS, SQL, Java, JavaScript, all this good stuff, right? There's no way that would bring any known vulnerabilities, right? So, let's go dip our toes in and see, right? I mean, sure, it brings in lots, but here's one I just happen to be aware of. Oops, I'm always forgetting to take the command. Right, and then BC Prov 150, like that's pretty old. Let's see what does the internet think of that? Snake has a nice website. And sure enough, right? Like, look at all these vulnerabilities. I'm from version 0 to 166, from version to 161, from version 0 to 156, right? It's just some mediums. This critical, no, it doesn't affect it because we're on 150. The highs, yeah, so this high is going to affect it because 150 is between 147 and 156. So it's funny, you go to SNCC's website and they're saying, yeah, this BC Prov jar file has lots of vulnerabilities. But then when I go here to their scan of Jira, right, my Jira image, they're saying, no, nothing found. So it's a bit odd, isn't it? Like, SNCC knows about this vulnerability, but because they don't look past the packages in package management, they're not able to detect it. Now, maybe the vulnerabilities don't matter because of how this jar file is used, but I kind of go by the philosophy, it's a lot of work to figure out if you're vulnerable. It's a lot less work to just patch. Okay, again, right? How can known vulnerabilities go live in this application layer, in this Jira layer? Well, it's got hundreds of jar files. Let's see, how many jar files do we have here? Right, yeah, like almost 1,000 jar files. Okay, that's JDK, so that's Java, but in the Atlassian here, I'll just filter it so it's only the Atlassian ones. Right, okay, so over 600 jar files that Atlassian Jira has brought down. A lot of those are going to be open source libraries, right? And so a lot of them are going to have known vulnerabilities published against them. How can we detect them? Well, you could manually cross-check them all against NVD, I guess. Or you can bring in some tools, right? So maybe OWASP dependency check might help download it into the image and just run it. We've got Java. All it needs is Java to run that tool. And then how can you mitigate them? Well, if you find CVEs, maybe email Atlassian, ask them to patch it. I'm on the latest version of Jira here, so this is kind of a tough one. Now, Jira is really meant to be a stand-in for applications that you're developing in-house, right? And so another idea you could do is take a software composition analysis tool like Dependabot install it on your Git. It actually comes pre-installed on GitHub, and it will give you early warnings. It'll tell you, oh, your Git repository is using a vulnerable library. You might want to upgrade that library. So it'll look at your source control and tell you right in source control. So that's a way to get the developers to patch before they've even built and deployed and delivered the system to the customer. Yeah, so we've already done this. I've already pushed to Docker Hub to see the vulnerability scan, and there was no vulnerabilities. And then, you know, the final bit for this talk is Jira plugins, but I've run out of time, so I think I'm going to wrap up here. But, you know, what you can do in a running Jira, so I've got this Jira, is I can actually extend its functionality further by installing plugins. So you go to the manage apps, and I've screwed up the networking with my Docker, and so it's not able to connect to Atlassian's marketplace. But I pre-downloaded this plugin, right? 18 megs, install it. And so here you go, like even more open source libraries are coming along for the ride. I know that this, it looks like it's just a single jar file, but it's actually not. It's many jar files all combined together. So for example, it contains Jackson, data bind, and what version does it have? Right, like pretty old version, right? So there's probably going to be a lot of known vulnerabilities from that. And it's an additional challenge here because all of the libraries that this plugin is using are all combined into this single mega library. They're called Uber jars. And so that's just a quick glance at that. So even when you are installing plugins, that's yet another vector through which known vulnerabilities can arrive. You can use Docker diff to sort of see if the plugin has altered Jira at all. But you know, you can also just look at the plugin itself. I just downloaded it straight to disk and opened it there. And then yeah, cracking open jar files, try and reverse engineer these Uber jars, right? Like I am aware of one tool that can handle this, but I'm not allowed to tell you its name. So in this case, how was I detecting that it was a vulnerable version? I was actually looking at the metadata in the jar file. So if there was no metadata, it would be pretty hard to tell that it was a vulnerable version of Jackson data bind. And how can you mitigate it? Well, now you're going to be emailing the plugin vendor saying, hey, can you guys upgrade that version of that library, please? Yeah, so to conclude this talk, I feel like we're in the early days of container scanning. Existing scanners, in my opinion, they're not very good. They're really focused just on the package manager. And, you know, like, honestly, I think they should have alerted on that glibc package just because I'd gone and downloaded it myself, right? Like, why aren't they picking that up? And then also conversely, I think, you know, all those Ubuntu alerts they're raising, even though I'm on latest and greatest Ubuntu, it's not useful to me. So sort of worst of both worlds. And then they don't seem to have any visibility into things outside of the package manager. Right? Look, if you're not installing RPMs or debs or APKs, they're totally blind, it seems. If people are aware of a container scanner that's not so blind, I would love to hear about it. If anyone's evaluating a container scanner like Aqua or SNCC or all these various container scanners, here's some advice for really exercising them, right? So make sure you make images with known vulnerable older packages to see what the scanner thinks. Definitely avoid scanners that, you know, instead of saying we don't support this image type, they are saying no vulnerabilities. I showed you Aqua doing that with my Alpine image. And then, maybe throw some weird stuff at them, right? Like you can use the alien command in Ubuntu and Debian. It converts RPMs to debs. Let's see what the container scanner thinks of that. Right? And then, all these debs that these companies now give you to install, right? Like that's how you install Zoom is on Linux, is through a deb. So if there's no vulnerabilities with that, can the container scanner catch that? And then finally, as practitioners in application security, what should we do? Well, definitely use container scanners. They're definitely better than nothing. Also, always do the dist upgrade or always do the APK upgrade at the beginning of your Dockerfile. So, these two things are going to help you a lot. Number three, set up something like Dependabot so that your own application libraries are avoiding known vulnerabilities as early in your development lifecycle as possible. And finally, a binary-based SCA scanner is useful as well. So OWASP dependency check is binary-based. It's looking at the metadata and the names. Whereas, others are looking at the build files. So I'm saying you want one that's looking at the end result artifacts. Yeah, so that's my talk, the 6 ways that vulnerabilities sneak into Docker containers. Stale base images, stale final images, off-roading packages, right? So, an APK file that didn't come from Alpine team, off-roading big tars of stuff where you just like download a big Oracle Java tar and just untar it straight to disk, your own applications libraries, of course, and then even stuff that you might install during runtime. Okay, thank you so much. Sorry, I went a little bit over time. Have a good rest of your day. Enjoy the conference, and I'll be here for a Q&A as well.